Tapping Life Math and History, and we're gonna be doing guessing the point on a trend line. So in the past video, the previous one, we were learning about how to guess what the trend lines look like, and we were also doing how to measure the correlation's accuracy and how strong they were. But we're gonna be guessing the points on a trend line. So use the equation that the trend line fits best. Use that equation to find the difference between acceleration rating in Car Crushers Roblox versus the top speed of a car. So if you ever played Roblox, there's a game called Car Crushers that you can actually crush cars and destroy them for fun to gain money and earn new items. So for the x-axis of our data, we have the acceleration rating. This will become in whole numbers or decimals, but the graph is going to be by twos. The y variable represents the top speed of a car, but in miles per hour. And the data right here is actually different car brands that are used to measure the acceleration rating in the game versus the top speed of the car. Oh, and if you're watching this in the United Kingdom or other countries that use kilometers instead of miles, remember, when you convert from a mile to a kilometer, you multiply exactly by 1.609 hundredths. So, we have, for a kilometer, every 0.2 miles is equal to a kilometer. So use this formula here to multiply all the data to get to kilometers. So the acceleration rating and the top speed of the car in miles per hour, we're gonna use Desmos to see what the trend line looks like at its best fit, because this is not a perfect dot of lines in a row. It's gonna be a little bit off, but let's see what the perfect trend line is. Well, almost. Let's get started!
Meanwhile, 6 hours later that same evening.
So on the ratio table, we have x representing the acceleration rating and y representing the top speed of a car in miles per hour. These are different car brands, and these are the kind of cars that are listed on this graph. So when you take a look at the data right here, if you take a look at on a graph, if you zoom out, then this right here is what the line looks like, or what it will look like. What we have to do next is type in y1 is approximately to mx1 plus b to see what the best line fit is for all of this data. So the results we have when we type in that strange equation, R represents how accurate the line matches up with the dots. They are not perfectly aligned, but 97 is what we get as our accuracy, because when you have R equal 1, that means that a line is a perfect fit and is aligned with all the dots in their respective order. But if you have R equals 97, for example, 0.97, that means it's not perfectly accurate because there are some dots that are a little bit off the line, but somewhat accurate. That means that 0.97 is really, really strong. So going back to our information, M represents the slope, and that's 13. round it to the nearest one. And your starting position, or B, is negative 3.6. Oh, we're gonna round that to negative 4. So, here's our equation that's the best line fit. We have y equals 13x minus that by 4. But no car can have negative 4 as their starting position. When you have speed or acceleration, you only have it as positive numbers. So this is where the guessing comes in. Just like the last video, we were calculating the age versus the height of a human. And when we did that, we got a score, or we got accuracy of r equals 0.24, which isn't really strong. The data wasn't very strong. But it clearly does show that in that lesson, we were making guesses and comparing them to find out what the most accurate line is. But this time, we're going to use the line that Desmos came up, the one that best fits, to predict what happens if use your equation to find the acceleration rating of a car if the max speed is at 150 miles per hour. So when you're trying to do this, we're going to rewrite the formula. Y equals 13x minus 4, but instead, we're going to insert 150 miles in for y. Because when we take a look back at our graph, y represents the y-axis, the top speed of a car. So we're going to say 150 miles per hour equals 13x minus that by 4. And we simplify to get x alone, because x is our acceleration rating. And in this scenario, we were trying to find what the acceleration rating of the car was. So, we're going to add this side by 4 to get this side by 4. So 154 equals 13x. When we divide 13 on both sides to get x alone, we get an answer as 11.8. That is the acceleration rating in car crashers. A car that is 150 miles an hour will have an acceleration of 11.8. Let's move on to our next scenario. But instead of trying to find the acceleration, it's the exact opposite. So, use your equation to find the speed of a car when the acceleration is 18.0. So this time, we're trying to find the speed of the car. So instead of inserting something for y is going to be our unknown variable. So, we rewrite the problem, y equals 13x minus 4, because it's a good habit to get to. So, since we know what the acceleration is, and the acceleration rating is your x variable, and it's 18.0, we're going to put 18.0 right here, or just 18. Now, we have to find out what y represents. So, we have 13 multiplied by our x, which is 18. We get 234. But then, we have minus that by 4. So when we minus that by 4 by 234, we get an answer as y equals 230 miles per hour. That must be a race car. The acceleration of 18.0 must belong to a race car in car crushers. So that is how you find miles per hour if you're trying to find it by having the acceleration as a known data. That is how you guess the points on a trend line with your y and x variable. I hope this video has helped you. Thank you for watching Taoping Airlines Math Industry. Like and subscribe.